Hello, everybody. Thanks for joining us today. So the goal of this workshop today is to talk about the Sensor Fusion XiL testing. Have the pleasure today to be with Ram Mirwani. I'm Sylvain Philippe, working for AVSimulation as a pre-sales manager. And Ram, if you want to introduce yourself, that would be a pleasure. Thank you.
Sure thing, Sylvain. This is Ram Mirwani. Hello, everyone, from Konrad Technologies, and I lead the ADAS and autonomous driving capability for testing at Konrad Technologies at a global level.
Thank you, Ram. So should you have any question during this web session, feel free to ask it over the chat. Please put your name when you ask the question. Don't ask your question as anonymous. So if we don't have enough time to answer to these questions, we will get back to you after the session, of course. So please put your questions into the chat with your name. Thank you very much. So let's start. Thanks, Ram, for being with us today. I'm just gonna have the laser here so I can point out. So about this first step, I'm going to just quickly remind you about AVSimulation products and services. So AVSimulations offers a scanner software suite, okay, which is a suite of 3 software: Studio, Explore, and Compute. Scanner software is an open and modular platform that can help to connect any standard, configure any input-output channels, data logging, communications, and etc. So it is widely used over different simulation platforms like workstations, big simulators, of course, and you will see today that it's going further. And thanks to Konrad for working with us on such project. We also offer that AVSimulation simulators. So we design and we maintain different operations on simulators. So if you are interested in, just let us know. And please be aware that we also offer services. So if you want to integrate scanner product, AVSimulation simulators in your existing ecosystem, I will say, just feel free to ask. Just to get back to scanner software, so related to this project, as I said, it's an open and modular platform. So this is the reason why we've been working also with Konrad Technology, because Konrad Technology Workbench is modular and scalable. And together we've been able to prepare and offer a bench for ADAS sensors package testing. You will see today that we made it for camera, but also what is important is to understand why do we need to use today, I will say, XiL test on this and go further than all the simulators you may know. So I think on that part, Ram will have good advice and good experience. So Ram, I'll let you the mic, and thank you very much for being with us today.
Thank you, Sylvain. So the basic premise here is when we think of an ADAS development path, and over here on this slide, you see the typical V development flow that has multiple steps of in-loop testing. So you have model in the loop, and then you go into software in the loop, which is mostly software simulation. And then you go into hardware in the loop, which you have the software simulation components and models, but you now bring in the ECU. That's the typical form of hardware in the loop. And then you get into driver in the loop, and you get into vehicle in the loop as the concept of the vehicle takes shape. Now, as you go through this V development flow, there are multiple instances where you have the opportunity to evaluate the ADAS functionality and the autonomous driving functionality. And what we have been working on at Konrad Technologies is to have a test platform that can enable the simulation, but also enable the testing of the ADAS capability. And today, what we're happy to share with you is how we can connect with the scanner software platform and be able to have this co-simulation between the hardware components and the software simulation environment. Next slide, please. So the overall concept that we're going to go into detail in is shown in this high-level diagram, where you can actually have a scanner simulation that shows a drive, right? It's a drive test, but it's a simulated drive test. And you are able to bring the actual sensors and the actual ADAS software functionality, the algorithms, into the test loop so you can validate and verify the performance of the ADAS and autonomous driving capability in a lab setup. And the way we do this is you have a scanner simulation, and according to the simulation, the object data stream for the different simulators is then sent to separate systems that function as simulators, and you can then actively stimulate the sensors according to the drive scenario. And when you do that, the output of the sensors can then be collected and sent back into the scanner simulation. So you have the capability for open loop simulation, where you're just stimulating the sensors and verifying they're performing correctly, or you can collect the output of the sensors and bring it back into the scanner simulation in a closed loop setup. So we have both of those capabilities. So in a nutshell, this slide shows the high-level architecture of how you can bring sensors and the ADAS and autonomous driving software components into the overall test loop. And then that's a concept that we call Sensor Fusion XiL Test, because you can apply this capability to any step of the XiL loop. You can apply this for model in the loop, software in the loop, hardware in the loop, driver in the loop, and vehicle in the loop stages of the testing. Next slide, please. So as we go into detail of this concept, and we want to show you a video of an application that we build with a camera. As we go into that, let me dive a little deeper into why this is important. Next slide, please. So as ADAS and autonomous driving capability is gathering a lot of steam and adoption in the automotive space, we are, from the Konrad Technologies perspective, as we are focusing on this area for over the last 10 to 15 years, we see a couple of challenges that have started to surface. The first is, the safety responsibility and the legal impact of ADAS functionality and autonomous driving. There's a huge discussion going on, especially with the unfortunate accidents that have happened involving autonomous driving vehicles. And there is renewed sense of urgency in how the ADAS and autonomous driving functions are tested, validated, and then put into mass deployment. So that's a big challenge. How can we do this safely and reliably? And then coupling that is the short time to market. There are new functions that continue to be developed, and also continuous updates that are being sent to vehicles. And this combination is really putting a lot of challenges on effective evaluation of the ADAS functionality in a way that, number one, can be done repeatably and safely in an environment that's contained. And then number two, as new regulations come up, how can the testing be done in a way to confirm that it will meet the regulatory standards that are being created in many different parts of the world? So this combination of challenges is definitely putting a stress on the OEM components, but it's now also floating back to the tier one manufacturers of different key components for the modules that relate to ADAS and autonomous driving in the entire supply chain in the automotive segment at this point of time. So faced with these challenges, what Konrad Technologies have been working on is how can we create a test platform that can enable this kind of testing in a safer environment, a lab environment. And today I'm going to be sharing some of these details with you, and also our partnership with AVSimulation and what we can do together. Next slide. So the basic approach at this point of time, when we think of the typical test process, is you have software simulation that is an established method where you have different vehicle components that are created in models, and then you have the ADAS components that are created in models, and then you're able to co-simulate multiple software models to make sure that everything is working. And this approach has been established with different hardware components in the XiL kind of V development flow that I just showed. And this is also a common practice. And what happens is, as you go through the development process, you actually get into bringing the actual vehicle components to co-simulate with different software models. And that's also a tried and tested test methodology. And all this is leading up to the drive test, which is still seen as one of the most important gatekeepers for automotive functionality, is to put it through the 100,000 miles of driving and see how the vehicle performs, how the functions are performing, right? And what we are suggesting now is there's an additional step that can be brought into the V development flow and into this test method, where before you get into the drive test, you can actually perform Sensor Fusion HiL Test, where you can bring in the sensors into the co-simulation loop and be able to have another degree of testing before you go into the drive test. And of course, specifically for ADAS and autonomous driving, which have a strong reliance on the sensor component for perception, and then there are intelligence and software components that are within the vehicle. So this new technique allows another level of testing before you get onto the drive test. Next slide, please. So this high-level concept is what we have conceptualized. We're starting from the left, and I'm going to explain in terms of a HiL setup. Starting from the left, you have a scanner drive scenario. And as you go through the drive scenario, the different models for the different sensors are working according to the drive scenario. But then the object data is then sent out of the typical software simulation environment into a hardware in the loop platform that is also running the vehicle models, right? And this hardware in the loop platform, and there could be a variety of different real-time platforms that perform this operation. This platform can then connect to what we call the Konrad Technologies ADAS HiL Test Workbench. Now, this workbench combines several separate systems and that function as simulator systems that can be connected into a single workbench. So we've got a simulator for camera, we've got a simulator for radar, we've got a simulator for LiDAR, we've got a simulator for ultrasonic sensors. And so this object data for each of the sensors is sent to the simulator system, and the simulator system in real time is stimulating the sensors according to the drive scenario. And in this way, the output of the sensors can then be collected and sent back to the drive scenario to complete the closed loop operation if needed. So by doing this particular test method, there's a couple of key points that you're able to test. The first thing is you're able to verify, is the sensor working correctly? And that's what we would call module level testing. But then when you combine the sensor performance with the ECU model test, then you are now doing a subsystem level test to enable the right intelligence. And then if you connect that to the vehicle model test, now you're able to do system level test. So with this setup where you connect the scanner platform together with the ADAS HiL workbench from Konrad Technologies, you're able to, with a single platform, be able to perform sensor level test, subsystem level test, system level test in a lab environment with a single platform. And so there's also a lot of benefits in terms of sharing what you learn at each of the separate stages as you go into the different types of testing, so you can also optimize faster. Okay. Next slide, please.
Thank you, Ram. I'm gonna explain you the scanner steps that you will be able to achieve with scanner software product. So if I'm going from the left to the right, so scanner and has Konrad Technologies is an open and modular platform. So if you want to use scanner and prepare your models with scanner software, you will have all the tools to create your models, your data, has your environment. You can also benefit of our features to import your environment. So if you have already existing models for environment, but also for vehicle dynamics, you will be able to use all of these parts inside of Scanner to prepare your experimentation, to design your experimentation. Based on these, so you can design also the different situations and events that you would like to trigger, and we offer also in Scanner a GUI. Okay, it's a GUI mode to prepare your different sensors models, and depending of these, we offer also several levels of sensors, from I will say functional sensors models till physical sensors models. So all of these models can be created from scratch, imported into Scanner, and also we offer default standard models. All of these models then can be used thanks to Konrad Technologies and AVSimulation platforms, open and scalables. All of these can be integrated with systems. So here we in the application we made, and we will show you today, we have been using a camera. Okay, so that's to illustrate that you can you can integrate various systems and software with both of our situations. And then you will simulate. So as I said at the beginning of this presentation, we usually talk about simulators, but simulators are not only what we have in our head about big driving simulators with a 360 degrees dome and etc. So no, we have been working with Konrad Technologies to integrate and interface Scanner and the system with Konrad Technologies platform. And so Scanner cannot be executed on any real-time targets. Okay, and at the end, when you are ready when you have integrated your system with the platform, then you can execute, of course, the simulate it, and we provide inside of Scanner all the tools to analyze any data you may have simulated. So that's a 4-step demo process. You prepare, you integrate your own models. It's full. You have a full graphical interface in Scanner. You integrate the physical model you want. You simulate it on a real-time target bench, and then you have all the tools to analyze. So if we focus now a bit deeper about the real-time solution for AVSimulation. So AVSimulation offers the real-time targets pack, which is a software pack, which is an add-on of Scanner Studio software. Okay, the real-time targets pack includes an easy way to exchange data between Scanner Studio platform, and any external program. And this communication is bidirectional, and it is based on UDP package. So this is the reason why it's open and modular, because UDP is of course standard, and that's the reason why we are able to communicate with any external program and any real-time targets like AnyVeryStan, DSpace Calexio, OpalRT, iHawk, and etc. So based on this and focusing on our topic today, we have been applying this method, and thanks to the AVSimulation real-time target software pack, we have been working with Konrad to interface Scanner Studio platform with Konrad HiL Test Workbench based on National Instrument VERISTEN. So we have been using that for the bidirectional communication with Konrad technologies, and on VERISTEN, custom devices have been defined in order to be generic, okay, as much as possible. And so all of these allows you to communicate very easily in both directions with Scanner Studio. And of course, all of these can be then applied to different systems, okay, as a RAM set, camera, radar, LiDAR, or ultrasonic. So if we go a bit deeper into the different, I will say, communication steps, and to show you the closed loop, I'm gonna show you another architecture. Okay, so on the left part you will have AVSimulation products. On the right part you have Konrad Technologies product, okay, based on VERISTEN. Here we do have, so this is the application we made with Konrad. Okay, so you have here the system and the stats, which is a mobile eye camera. Okay, so how it works, how works the closed loop. So on the left part you have Scanner Studio software with the simulation environment where we produce the image. Okay, and this image is displayed and is projected on a system. In our case it was a screen. Okay, but it can be of course anything, and you have a camera in front of the screen. Okay, and then the goal is to establish the communication, the bidirectional communication, to close the loop between both architecture. So if we go deeper, we had to prepare I will say a channels manager for inputs and outputs. And so how it works, we get the output of the camera, and all of these outputs are sent back to the real-time targets pack inside of Scanner. Okay, so all of the outputs from the camera are filtered by the channels manager and sends to Scanner environment, and then all of the inputs becomes available in Scanner environment and can be used to trigger any information to the driver. And it's bidirectional, and that's what is very interesting. It's, you can also, if you want and if you need, and that's why we have a closed loop simulation, you can of course send back information depending of the information you would like to display inside of the camera. You can send back information to the camera in order to take it into account. So that's a bidirectional communication based on generic custom device that we made together between AVSimulation and Konrad Technologies based on AVSimulation real-time targets pack. Something that I would like to point out as well before to continue is that the Ego vehicle here, okay, so you have inside of Scanner Studio different models that you can define. Keep in mind that we are open architecture inside of Scanner. As I said, if you have your own models, you will be able to import your own models and prepare your own models for Scanner. And we are proud to say today that the Calas Dynamics model, which is AVSimulation Vehicle Dynamics model, is also compatible with real-time platform. So Calas Vehicle Dynamics model is able to run on any VERISTEN, NI VERISTEN, also DSpace Calixio. And if you need other architecture, of course, we are able. So Scanner can be available on every platform, on any platform. So on the next slide, we do have an illustration of the project we made. Okay, so you can see at the bottom here the camera. Okay, we have the screen with the Scanner visual rendering here, and you can see that the camera here detects the different situations of the vehicle. So we have different kind of applications based on Endcap scenarios. Okay, so that's generic Endcap scenarios made thanks to Scanner different tools. So here you have the sign detection. Okay, so we get the information to the driver that the speed is changing. You also have lane detection, which is taken into account. So you have the camera looking for the visual on scanner, and it gets back information to the driver about the different markings detected. And as you can see, we have the closed loop between also the distance between my vehicle, which is in front of me, and also between my vehicle, from my vehicle to the vehicle in front of me. And here we have the information getting back to scanner. Okay, Ram, would you like to add something, Ram, on that part, or is it fine for you? Should I get back, or is it good
No,
for you?
I think the demo video clearly demonstrated a few points that we have noted on this slide. And the key points that we covered is, in the scenario, we demonstrated lane departure warning, and also several additional capabilities. And the way this particular demo is set up is we have the image creator that is creating the images that the camera should be seeing, and that is being sent to the projection screen that you see over here. And then the Mobileye camera is sitting right in front of it and in real time processing the images as if it was in a drive scenario. So, you know, the key points that Sylvain went over is really to highlight the different scenarios that can be implemented, the capability for closed loop and open loop testing that can be done. So you can just verify the camera functionality, you can communicate with the camera and combine that with the ECU if that is another way, another type of testing that you want to do. And of course, this capability can also be done at the vehicle level, where you can have the same setup mounted in front of a vehicle, and if the camera is already mounted on a vehicle. So this demo was really to showcase the connectivity that is currently available between the AVSimulation platform and the Konrad test workbench with all the sensors. In this demo, we're just showing camera, but you can very easily extend that to include a complete sensor package. Right.
Thank you, Ram. Okay, I give you back the mic also for the next part. Yeah.
Excellent. Yeah. So a couple of things that we uncovered as we went through. We were very specific in wanting to implement some of the scenarios that we have learned as we have worked with different customers in deploying this test capability. And so the couple of things that we showed, the first one is lane departure warning, that was shown in the video. Then we also did object cut in and cut out, which is a very important test for ADAS and autonomous driving, is for the vehicle to be able to sense when there's an object in front of it, especially when it's doing a lane departure. And also the important thing in this demo is, when we say lane departure, is the tracking of when the object is in the lane and when it's moving to another lane. And that was also shown. And then of course, closed loop and open loop testing, as I've discussed a little bit earlier. Now, one of the points that kept happening in this video is, as we were going through the scenarios, you would see the real-time updates for the dashboard and the alarms, and that would be the closed loop portion, right? So you have the open loop, the closed loop testing, and then we have started implementing several of the tests according to Euro NCAP scenarios that have been released. And this is also a capability that is there in Scanner together with UTEC SRAM. And then we'll have a slide on that capability in a little bit. Okay. Next slide, please. So what are some of the benefits of Sensor Fusion XiL Test with the Konrad Workbench and Scanner platform? So the first is, you can now connect the software simulation with hardware simulation data, right? So you can have your system, you can conceptualize your system, you can create the models of the system, but now you can combine the testing with different combinations of models and the actual hardware components, and you can bring them together to perform different levels of testing, where either you want to test the software models, or if you want to test the hardware components, for example, the radar sensor, and you want to see how the radar sensor works with the emergency braking algorithm that you've created. Now that's possible because you can mix and match different components in this setup. Now, along those points, you can now bring in component level tests, subsystem level functional tests, so you can separately validate, is the radar working correctly? Excellent. Is the radar with the ECU working correctly? Okay, that's working well too. Is the radar with the ECU and the braking mechanism, is that working correctly? Okay, so that's how you're moving from just sensor test to a subsystem test and then getting to system level test. And you can do all of that with this combined platform. And the next step is to be able to perform this level of testing in a lab setup. So this is before you go to the drive test, which is pretty time intensive and pretty expensive. But now in a lab setup, you can optimize your test with the different software and hardware components so that you can create the best possible version of it before you get to the drive test, right? So that's definitely possible. So now with this lab setup, you can do reliability testing, you can do stress testing, regression analysis. You can come up with a scenario and run it, let's say 200 times in a lab setup and determine how does the sensor work? How does the camera work as you run the same scenario 200 times? And does it work repeatably? Does it work reliably? And at the same time, do the components work as you expect it, if you run it in the 200 cycles? So you can do that type of testing in a lab setup, which is very difficult to repeat in a drive test kind of setup, right? And very expensive as well. So that's definitely possible. Next point is you can customize your test application for your sensor package. So if you have multiple cameras, if you have multiple radar sensors, it's definitely possible to scale this Workbench concept together with the scanner application to meet your sensor package. And at this point, you see varying combinations of sensors that are now being used for ADAS and autonomous driving capability. And so this kind of flexible platform that we have with the scanner software simulation toolset together with the ADAS test Workbench, this combination can scale according to the sensor package. And this then leads into the next point, which is future proofing. So as you develop your sensor package, you release the first version, and then you are updating your sensor package. Well, now you are able to put that incremental increase into your test system because the test application that we have is modular in nature. So you can add a sensor, you can add a new sensor. That is something that's definitely possible. And this leads into the last point, which is support for evolving standards. There's been a lot of debate. There's been initial versions of different standards like Euro NCAP, which could be regional based and have differences in the different regions between Europe and US and China. And then you have SODIF that's been developing in the US, and that's gaining ground on how to test some of this different capabilities for autonomous driving and also getting up to level 5. But before you get to level 5, how do you test for level 3? How do you test for level 4? And as these standards are evolving, how the ADAS and autonomous driving capability has to be tested in order to release that capability is also going to evolve. So with this change that is definitely going to be happening over the next 3 to 5 years, having a scalable and modular test platform will enable the users to be able to improve their testing in a lab environment before they get to the drive test. So next slide, please. So here is what the test workbench, or here's the image of what a test workbench looks like. This is one of the configurations we have. We're moving from the left. We've got a front radar test system, and then we have the side radar test system. And then we have a HiL system, which is running all the vehicle models and also connecting to different software simulation packages. And then we have a brake simulator, okay? followed by a steering simulator. And these two components are the vehicle components that we are bringing into the test loop because we wanted to test emergency braking, or we wanted to test lane departure warning. So we have to simulate the movement of the steering or the movement of the brake, right? So that's brought into it. And then the next component we have is the camera simulator. And of course, this setup can also involve a driving simulator. Right. So this complete test workbench has been deployed several times now by Konrad Technologies and being used for ADAS and autonomous driving tests together with sensor validation. So the next slide, please. So in this particular deployment in China for one of our customers, what we basically did is we have this particular flavor is set up for HiL testing with the front radar and the side radar and the camera simulator. And this was the first step leading towards being able to test not only the sensors, but the sensor with the software ECU for ADAS and moving up to level 5 was the intent. Okay. So this is a deployed version, and we have several of these around the globe. Next slide, please.
Thank you, Ram. So as Ram said, you will have in the near future, and I will say no, new challenges also to test and evaluate and validate your ADAS system and of course autonomous driving. So we know that to test all of the possibilities, you will need to have more and more situations and various situations, and also of course do more and more numbers of kilometers, of miles. And all of these tests and all of these miles and all of these situations cannot be done without the simulation. That's the reason why AVSimulation over the scanner software product has been working to offer to our end customers Endcap scenarios that I will include you right now. And of course, these the simulation so will allows you to evaluate and validate your ADAS systems in various situations over a number of kilometers, which is not limited, but it will also save, of course, time to market, and of course it will be less expensive, because when you have to do testing on a proving ground, on a physical one, you will have to do from, I will say, at least 5 tests up to 10 tests, and all of these request preparation on your side, and then go to the test, and it's quite expensive. Thanks to the simulation, you will be able to divide this kind of amount by 2. Okay, so we have been working with Sensor to prepare scanner studio scenario for Endcap situations. Okay, why we have been working with Sensor? Sensor is an organism which is a specialist in Endcap testing. And thanks to their unique experience, they have been able to create scanner scenario, okay, on the shelf scenario to test and validate all your ADAS system with scanner software. And so their experience is very important because it takes into account, of course, all the properties of the proving ground that someone who is not a specialist cannot have. It also includes the driving robot models. Okay, so of course we do not have a human driving the vehicle, we have a robot, and this robot is very sensitive, and all this sensitivity has been taken into account into the strategy of the robot, and we also provide you the scoring. What is very interesting to observe is that what we call basic control is that we know that some of our customers, some of our others companies propose some Endcap scenarios, but these, I will say, are basic control because they are representative of Endcap scenarios, but they do not take into account all the experience of HiL regarding the proving room, running surface, all the driving robot models. And we can observe, thanks to the HiL control based on its experience, okay, you have here on orange in amber here the real test line, okay, and in green over the result that we observed with the scanner HiL Endcap scenarios, okay, and we can see that we have 60 centimeters of gap between the basic control that someone can do on his side without taking into account the proving ground, running surface, without taking into account the driving robot models, and here the result we get. So we have less than 1 centimeter of results, so which is great, okay, and with basic control you have more than 60 centimeters, which is complicated because at 60 centimeters this guy here will be dead, okay, so that's very important to have accurate and a representative environment for that. So that's why we've been working with HiL and we now offer I will say scanner scenarios for Endcap testing. So all of these testing are available for Euro Endcap, US Endcap, China Endcap, and we work on Japan and Korea Endcap as well. All of these are available for test. So if we get back to this, to sum up of other main schema that Ram has introduced to you today. So keep in mind that we are at AVSimulation with scanner software. We have an open platform which can be mapped with any, I will say, external platform. Okay, and at Konrad Technologies, we use scalable, open and scalable platform to test and validate any of, I will say, external systems. So we've been integrated and we have made a bidirectional communication between scanner environment and Konrad Technologies test workbench. We are able to run Cala's vehicle dynamic or any other vehicle dynamic model on a real-time platform. And you can integrate any type of sensors. And that can be a closed loop. Of course, the sensors can also send back information to your environment, so the vehicle dynamics model, scanner, and etc. So it's a closed loop situation. Ram, would you like to add something on that part, or are you good on that?
Yeah, I think that was a good overview.
Excellent, thank you. So if we sum up that, so we have been seeing how to do, so the Sensor Fusion for HiL is deployed technology. It's not a dream, it's already existing, we made it. Scanner and Konrad Technologies are open and scalable platform, so it's something that you can use, and thanks to our experience and thanks to our flexibility, we have been able to do such project, and we of course will do future projects. So we do support any standard, as we said, and we have also add-on data that can be used in order to increase your possibility. So that's we have done for today on this workshop. Just to let you know that AVSimulation products are available for demonstration. Okay, so if you are interested in testing scanner software product, ask us the trial version. We also offer the Endcap Scenario for testing, okay, for evaluation. So if you are interested in evaluate or Endcap scenarios, feel free to ask. If you have we offer a weekly workshop every week. Okay, so if you are interested, do not hesitate to go on our web page to consult our agenda and register to the next event. We have all our videos and replay available on YouTube, and of course we have the video available about the Sensor Fusion HiL Test made by Konrad available on YouTube. So feel free to go over it. I think we have 1 minute, which is here. So if you have some of questions, we can answer. And I think I've seen some interesting one. One very important is that who should I contact? AVSimulation, Konrad Technologies to go further with such project. It's easy. Either one, okay? The more convenient for you. If you are working already with AVSimulation, contact us. If you are already working with Konrad Technologies, contact Konrad Technologies, and we will of course then work together to offer you the solution. So no worries. I think we have 1 minute. We have some other questions. Is there something specific, Ram, that you would like to add before we go through the questions? Because otherwise the time is gone now. So anything else you would like to add on that part?
It's been a pleasure to work with you, Sylvain, on this project and also on this webinar. And looking forward to any questions and going from there. Yeah,
sure. Excellent.
Thank you.
Thank you very much. Thank you very much, Ram, for your time and precious advice. Thank you to everybody who participated to this event. I do apologize if we haven't been able to cover all of your questions, but if you put your name, we will get back to you by email or phone if we have it, and you will get the replay on YouTube soon. Thank you very much, Ram. Thank you to everybody.
Thank you, Sylvain.
Looking forward. Bye bye.